Ladies and gentlemen, Python 3 has been released for many years, and after every year, they have a new version being released. So this year, we welcome 3.6. You may wonder what's new in it. Will it make a huge difference in Python 3.6? We'll figure out in this the third lecture. Let's welcome Brett Cannon for what's new in Python 3.6.
Well, thank you for the warm intro, everyone. So yes, my name is Brett Cannon. I work at Microsoft on the Azure Data Science Tools team. And I'm here to basically tell you what's new in Python 3.6. Now, I should start off and say, everything I'm about to tell you is already written out on the internet, so you can completely ignore me and still get the exact same amount of information, more or less. If you go to docs.python.org/3.6/what's new /3.6.html, you can also get to it just off of docs.python.org. As I said, everything is there, so if you miss something and want to read up on it later, it'll be there. So yes, if my Canadian isms frustrate you, you can ignore me. Another way you can also do this is I'm going to be going over the 16 Python enhancement proposals that help make up Python 3.6. So if you go to python.org/dev/peps, you can read the peps, get even more detail, and have yet another way to ignore me and still get the information. So once again, don't feel bad if you have to leave or anything or want to just tune me out. I understand. One key thing I want to say, though, about the point that there are 16 Python enhancement proposals is that is almost a record for Python. The only release since we started doing Python enhancement proposals that had more was Python 3.0, which we all know was a very large release. So that should give you an idea of the scale in terms of new features that have come into Python 3.6. So I just hope you understand that a lot of work went into this. And I really want to thank specifically everyone who participated in the 2016 Python core sprint that happened last September at Instagram. 12 of the 16 peps I'll be talking about were somehow worked on at that sprint. So I specifically want to thank Instagram for hosting and being the largest financial contributor to that. Microsoft for also being a financial contributor and letting me and my coworker Steve Dower attend. And the PSF for also helping pay for other people to attend. So thanks to everyone who helped make that happen. It made a huge difference in the scope of Python 3.6. But without further ado, I will jump into this. I'm going to go in numeric order for the peps, and basically just try to give you some background information beyond just what the feature is to liven this up a little bit. So without further ado. PEP 468, preserving keyword argument order. I believe this is Eric Snow's PEP, if he happens to be in the room. He's right there. Basically what this does is whenever you use ** KWArgs, historically it was just a dictionary. So that usually meant everything was randomized and you didn't know what order people actually specified keyword arguments in and make it a function call. What PEP 468 said was we are going to guarantee a mapping, not necessarily a dictionary, but a mapping that will actually keep order of the keyword arguments passed in a function call. Now, in Python 3.6, if you happen to be in Raymond's talk right now, you'd be told about how Python 3.6's dictionary actually keeps the order. I'm going to say this multiple times in this talk. Please do not rely on the order of dictionary, key iteration, or value iteration. It is an implementation detail. It is not part of the language. We only guarantee it in this specific instance in the language spec. So please do not rely on the ordering of anything coming out of a dictionary unless I specifically point it out. We might change that in the future, but I just know this is a place where some people might kind of get slipped up. So I'm going to reiterate that multiple times. But yes, as you can see, order is now kept. Thank you to Eric Snow. PEP 487, simpler customization of class creation. We've always provided a real rich ability to customize things in Python, specifically from the creation of classes. Like metaclasses are a great way to really control creating a class itself. But for anyone here who's ever tried to write a metaclass, you know there's a lot of little details. It's really messy and hard to get right. And then we go all the way up to the top of the scale where you get class decorators, where you basically after the class is created, you can pass it through a decorator, modify it, customize things in any way you want. But there's never really any middle ground. It's either all the way down the guts of Python in a metaclass, or all the way up after the class is already created and might be too late for certain things. So in Python 3.6, we added this dunder init subclass hook, where we pass you in the class, any keyword arguments passed into the constructor, and then basically just allow you to manipulate the class before the name binding happens. So as you notice here, what I did was I defined this PEP487 class, where when it's subclassed, the class is being constructed, the subclass being made gets passed in, and I just define a hello method that just prints hello to the keyword argument, as you'll notice, in the class line. Nothing fancy, but the key point is a nice insertion point between class decorators and metaclasses to let you customize your classes as necessary. PEP 495, local time disambiguation. This led to quite a discussion in Python Dev, and to the extent there was a complete date time sig created just for this problem. And it literally led to a single argument in a constructor. It shows you how dedicated you could say we all are on Python Dev to trying to get things right. So think back to November 6th, 2016. It's daylight savings time. You fell asleep. You woke up, and your clock next to your bed said 1:30 a.m. Has it been an hour and a half since the start of the day, or has it been 2.5 hours since the start of the day? You have no idea, right? Unless you actually keep your time zone to know which time zone it is currently, whether it's daylight savings time in terms of the time zone or after, you have no clue. So what ended up happening is we added this fold argument to datetime instances to basically say, has time folded back over itself or not? Now, obviously, it's best to keep your time zone in your datetime objects so this ambiguity doesn't show up, but we all know life's not perfect, and we sometimes don't have the time zone available. So this at least allows you to specify for that funky time during daylight savings where it's ambiguous, whether it's the first time through the hour or the second time through the hour, to know exactly where you are in terms of time. PEP 498, formatted string literals. Everyone loves this. I have yet to meet a single person who doesn't like this unless you're on Hacker News and you complain that we now have 3 ways to do strings, but you're still better off, so I don't care. In case you have not come across f-strings yet, which are so great, by the way, that PyPy has actually backported to PyPy 3, which is supposed to be 3.5 compatible, but also this. This gives you an idea of how excited people are from this. So if you notice on that third string there in the example, you might not quite notice it. There's an F prefix, much like the B prefix for byte literals or R for raw strings, et cetera. What you notice is the stir.format method's signature of how to specify arguments into a string, but there's no format call. What happens is the format string gets parsed by Python itself at compile time to the PYC files, teased apart, and then basically under the hood at the bytecode level ends up constructing the equivalent of the stir.format call for you. So not only is it cleaner because you no longer have to call stir.format, but it actually performs better because we can now infer things thanks to it being part of the actual literal to actually implement things at the bytecode level. So this is actually faster than stir.format. And all this is thanks to Eric Smith in the front row. So if you're not using this yet and you're compatible with 3.6, I highly advise you start using it. It gets very addicting very quickly. And just to appease those who are upset that there's now 3 ways to do it, the % way is just to be compatible with Python 2. And stir.format's still there because you do need to pass that around sometimes as just a callable object. So there's a reason we kept it. But anyway, this is a fantastic feature in 3.6. PEP 506 and 524. This will bring back slight nightmares for a lot of core developers because this was almost a month-long argument that even dragged in a Linux kernel developer. We take security seriously, but we also take backwards compatibility seriously. And what came out of all this is PEP 506, thanks to Stephen DePrano, we now have a secrets module. Now, a lot of you might know of random for randomizing numbers and getting that kind of thing. The problem is it was never meant for crypto or security-related anything, honestly. Random is really meant for simulations where you just need kind of a little fake roll of die that you can maybe reproduce in a test. The secrets module, though, has been designed specifically for crypto-level number randomization or anything else that you need to do that might be that level of need to be that level of safe and ready for security use. So basically, my key point is if you know you just are doing some modeling and simulation, keep using random. If you're not sure if this will ever have to be crypto level secure, or you honestly just don't know, or you do know, just use secrets. It might be a little slower than random, but you just do not want to find out later that you're using random and somehow it's now really security related and you screwed up and now someone's really mad at you. So use secrets if you're not sure. The other thing is PEP 524. This is the thing that really caused a huge kerfuffle on Python dev for a while. Basically, in Python 3.5.0, os.urandom would block until there's enough entropy in the system, because you have to initialize the random number generator to actually be able to make random numbers. The problem is, containers don't get a lot of randomization because there's not a lot to start up for those things. So if you start up a container, it can actually take a few minutes for a container to actually generate enough entropy if the container is not being used constantly to make that entropy. So, all right, that sucks for people if they suddenly have this fast container they started up, and yet now suddenly Python is making them wait several minutes. So we said, OK, in Python 3.5.2, we'll make it stop blocking, and we'll just fall back to /dev/urandom. Secure people in this room might be cringing a bit, because what we basically did was, by accident, was we caused os.urandom to no longer be very secure. Because if we swapped on you without telling you, you didn't know if you were getting the more secure random number generator from Linux or the less secure one. So what ended up happening is, in Python 3.6, we took os.urandom back to the blocking mechanism, and we added a new os.getRandom, which will actually not block, but raise an exception. So you can make a decision. Do you want to wait until there's enough entropy? Or you can choose to call another random call that won't block. So you can make your own decision. Explicit is better than implicit. We kind of screwed up by not thinking about that ahead of time. I'm very glad this got settled. PEP 509, adding a private version to dict. This was thanks to Victor Stinner, who's also in the front row. 98.9% of you will never care about this, and that's fine. Basically, we've added a version ID to dictionaries based on mutation. You can only get to it at the C level on purpose, because this is really meant for people who are going to be doing things like writing JITs for CPython or debugging and other things where they basically need to know if a dictionary has mutated or not since the last time they looked at it. So this is really a future-looking optimization in terms of ability to do things in Python. So it doesn't really do anything for anyone quite yet, but it will. I hope so. I'm sure Victor will make it go faster. Don't worry, it'll be worth it. PEP 515, underscores and numeric literals. Who here has ever written out a really large number with a bunch of digits and had to count to make sure they weren't missing a digit? Yeah. Funny enough, when I first wrote this slide, that said 1 million instead of 1 billion because I miscounted. OK? So I've definitely done that, and I did it publicly, too. So basically what happened is in 515, we decided to allow you to put underscores in numbers for the specific reason to be able to group them like this to make them much more readable. And as you will notice, we are pretty liberal about where you can put them. You can put them right after the base notation, so 0x, and you can do the underscore for hex, et cetera, et cetera. So it was just a really nice little touch that other languages have been doing and that we realized, oh yeah, we should have that too. This is thanks to Georg Brandl for coming up with the PEP and writing most of the code. And then I think Sergey and I finished it up. PEP 519, adding a file system path protocol. This is my fault if you don't like it. Basically what happened was someone came onto the Python ideas mailing list and said, you know, I really like pathlib, but I can't use it anywhere because everyone wants a string, right? Everyone calls os.path to do path manipulation and such. Why don't we subclass pathlib with stir? And then a big discussion broke out about how that's not a good idea because if you start doing that, everyone will expect stir to always work, which isn't true because taking the stir of none is going to always succeed, and you really probably didn't need to specify the file named none when something falls through. So it's not really good error reporting. So once again, being very explicit. So what we ended up deciding to do was we created a new protocol called it's at os.fspath. And basically, you see that under fspath method. What it's supposed to do is any object that represents a file path will return either the stir or bytes representation of that path. So it basically allows us to tell you, use pathlib as much as you want, and as long as the object defines that, it will just return the representation of the path. So we can view strings more as kind of an almost, not an encoding, that's not right. Stephen Turnbull would be very upset if I said that. It's a representation. And we've plugged this through as much as we can throughout the standard library. So os.path, for instance, completely supports this protocol. So if you're using an older library that's not aware of this and maybe hasn't been used very much with pathlib, it should hopefully just fall straight through and just work. And actually, a large part of the standard library just works with pathlib now, magically, because we just plumbed it through completely throughout os.path. So yeah, so basically, if you like pathlib, like Fernando Perez of Jupyter, who's the biggest fan I know of, you can now use pathlib wherever you want. PEP 520, preserving class attribute definition order. This is once again Eric Snow. He really likes things to be in an orderly fashion, apparently. Basically, when you define things in your class body, there was no guarantee you would get to know the order of their definition later on. With this, much like the earlier PEP where I talked about keeping the order of keyword arguments to a function call, this is the same thing, except it keeps the order of the definition of attributes in a class. Once again, we guarantee that dunder-dict will be a mapping that keeps order. Don't rely on dictionaries in general keeping this order for you. That's the last time we're going to bring this up. You've all been warned. PEP 523, adding a frame evaluation API to CPython. Once again, this is my fault, although Dino Wieland, my coworker, is also part of his fault too. This is part of the work we were doing at Microsoft with our pigeon experiment. If you were here at PyCon last year and saw our talk on trying to add a JIT to CPython, this was a key hook of ours to try to allow this. Now, once again, 99% of you are not going to care about this, but if you write a JIT or a debugger or a profiler, you're going to care about this. Because basically what this lets you do is there's a C-level call where we call into the function that's going to evaluate the frame of the function you're currently executing. Before, there was no way to configure that. It was just Python's job to just take the frame of execution and just make it run and do its thing. Now there's actually a place where you can insert a function to call instead. And this is really key with something like a JIT, because now we can catch the frame, decide if we want to execute it in CPython, or if we want to JIT it and run it through a JIT instead. So dream of dreams, this is what will let us put JITs on PyPI and have you just install a JIT through an import statement. I should also mention PyCharm's latest release has a 20% speed up in their debugger. It's because of this hook. I should also mention this also added a little internal C API for storing data on code objects. Once again, most of you aren't going to care. Only the people who care about the hook will care about that. PEP 525 and 530. This is Yuri Solenov and his work to try to plumb more async and await through Python. So Python 3.5 added the whole concept of async functions and async and await keywords. But we only plugged it in terms of normal functions that's either awaiting or returning. There was no way to do a generator that could also await on things. So what these PEPs did is basically made generators a possibility using await. So it seems kind of obvious, but we only had so much time for Python 3.5. One of the nice side effects of this, though, is list comprehensions on top of normal generator expressions are generators underneath the hood. So by making this work with generators, it now works with list comprehensions as well. So now list comprehensions can use like async for to iterate through the iterable that you want to work with. Or you can call await on a result within your list comprehension itself. So it's a nice little touch up, but nothing really critical. But it makes things nicer and smoother and just plumbs async all the way through Python. PEP 526, syntax for variable annotations. This is all part of the type hints stuff that you saw, for instance, mentioned at Instagram during the keynote that they've been using. Dropbox has been using this a lot. Basically, if you work at an enterprise company, you probably love these things. What this does is it allows you to add annotations to the variables. Previously, you could only do it at the function level, so you can only do it for the parameters to a function. Now you can go all the way down to the variable level. Now, much like with function annotations, nothing is checked at runtime. There is no real overhead other than anything that might need to be constructed or something if you specify something as a type in terms of the annotation. So there's no penalty for doing this performance-wise overall during runtime. If you define a variable annotation at the class level, it will be added to the dunder annotations attribute on that class, and it's a dictionary, so you can just key off of what the attribute name is and see what the type hint is for that. You can also do it at the local level in terms of local variables. Those do just get tossed. They are in the AST, though, for Python. So those are mainly there for performance reasons, are not kept anywhere because there's no real good way to expose them anyway. And they're basically there so the tools like MyPy can verify that your type hints have matched up to what's expected. PEP 528 and 529. If you're a Windows user, you're probably going hooray inside. If you didn't see Steve Dower's talk, he talked about this as well. The REPL now uses UTF-8. So I can actually put a little emoji like that and have it actually print out. If you're a Windows user, you're probably used to seeing your little emoji baked squares when dealing with some UTF-8, and that was always really annoying. That's no longer a problem. The other key thing here is Windows now takes byte paths. This is a really big deal for projects like Twisted, where their whole system is designed to work with byte-based paths, and Windows wouldn't accept it because they were deprecated since, I think, Python 3.2. So instead what's happened is on Windows, we now set the default encoding for the file system to UTF-8. And if you pass in a bytes-based path, we do the re-encoding to UTF-16 for the internal Windows APIs and handle all of that for you. So basically, you just treat paths as UTF-8 on Windows now. So it should make things a lot smoother for you as well if you're transitioning from 2 to 3 and you're dealing with byte-based paths. There's a couple things not in the PEP I wanted to bring up. One thing, this is also from Victor Stinner's Python malloc. What you can do now is through an environment variable, you can specify the debugging hooks for memory for Python itself. So you don't have to do a complete recompilation for a PyDebug build if you want to see where your memory is going and track that. You can use this hook to use different things. Or even just force use of malloc or other kind of mallocs to make things work the way you want it to work without having to do fancy recompilation stuff. I should also mention something that Łukasz Lenga of Facebook and Instagram added at the core sprints in September was dtrace and system tap support. I've been told dtrace and system tap are amazing, and people get really elated who use it, find out that we added this. I'm going to assume they know what they're talking about, so I'll be elated too for them. I haven't personally used this, but everyone I know who uses dtrace really loves this, so I think we probably should all learn some dtrace probably. You do have to compile this with a specific flag, -- with -dtrace, and what this currently traces is function calls and returns, when GC started and finished, and what line of code is currently executing. I believe Łukasz is totally open to adding more, but that's just basically what we started with, because that was what was in an initial patch that he took and made work. But as I said, everyone I know who uses dtrace is elated, so I feel like I need to learn dtrace now. A couple of things that aren't on the slides. We now warn you, for instance, when you use a / in a string that's not raw, and the following character doesn't make any sense. So you won't actually do /m and expect something to work. So you've got to worry about that. We've added a couple extra bytecodes, generally around unpacking, since we added all that generalized unpacking of iterables back in Python 3.5. That's about key that I can think of off the top of my head that's not on this slide. Now, I've had a slide for benchmarks, which you can see current results of at speed.python.org, thanks to Victor Stinner. If you really want to see a longer, more detailed discussion of current Python performance, watch Victor's talk. The recording might be up already even. But I'm just going to go over one quick slide and then start taking questions. But basically, Python 3.6 is fast. We should all be happy. If you just look at this graph real quick, there's just 4 app benchmarks that we have as part of our performance benchmark suite. 2 to 3, Chameleon, HTML5 lib, and Tornado. All this is normalized to Python 2.7 because that's what everyone historically bothers me about. As you'll notice, all the far left bar is the tallest bar, which means Python 3.5 and 3.6 is faster than Python 2.7 on these benchmarks. I don't know why Chameleon spikes a little bit on 3.6 that day. I asked Victor yesterday, and he says it's probably one of the unstable benchmarks. So I honestly should probably take it out. But as you can see, faster, lower. Python 3.6 is faster than 2.7. Instagram talked about how it's faster for them too, so 2.7 is slow now. That's the way I think about it. And with that, I will happily take any questions you might have. Thank you. And I believe we have 2 mics on the left and on the right.
Hi.
Hi.
I like f-strings. They're pretty cool.
Yes, they are.
In other languages with quasi-literals, you can play with them in other ways. You can use them as patterns. You can redefine the parser that's used inside the string, that sort of thing. Has anybody talked about that kind of add-on for Python f-strings?
Not to that extent. Eric is saying there's a PEP 499 to at least fully generalize it to any Python actual expression that you can evaluate, because right now there's some little edge rules because it made it easier to implement. So PEP 499 is sitting there to completely generalize it to any Python expression. The problem is the PEP author doesn't know C, so he wrote it saying he wanted it, and it should work with syntax highlighters and such, but then no one's ever implemented it. So if you really care, you can look at 499 and potentially write the patch for it.
I wrote my own language, but...
Oh. Wait. 501, sorry. If you want real key details, the man to talk to is right up here in the orange.
Cool, thank you.
No problem.
Hi, thanks for all the great work on 3.6.
Welcome.
I just have one question about the dunder dict on classes being preserving order.
Yeah.
Does that also extend to the dict of a module, either by accident or on purpose?
I'm going to go with no, because I don't want to encourage any accidents. So, and the man who obsesses over order says no, so I'm going with no. Yes?
Hi, do you profile memory usage on your regularly?
I don't remember off the top of my head. Zach Wave, in charge of the build bots, is saying no. So I'm going to go with no, based on my comrades in the front row. That'd be something to talk to Victor about. I don't know how difficult it would be to add. Since we are running on Linux, it should be possible. But Victor Stinner would be the best person to talk to about that. Any other questions? All right, well, everyone, enjoy lunch. Thank you very much. Python.org/dev/peps. You can read the peps, get even more detail, and have yet another way to ignore me and still get the information. So once again, don't feel bad if you have to leave or anything or want to just tune me out. I understand. One key thing I want to say, though, about the point that there are 16 Python enhancement proposals is that is almost a record for Python. The only release since we started doing Python enhancement proposals that had more was Python 3.0, which we all know was a very large release. So that should give you an idea of the scale in terms of new features that have come into Python 3.6. So I just hope you understand that a lot of work went into this. And I really want to thank specifically everyone who participated.
Ladies and gentlemen, Python 3 have been released for many years, and after every year, they have a new version being released. So this year, we welcome 3.6. You may wonder what's new in it. Will it make a huge difference in Python 3.6? We'll figure out in this the third lecture. Let's welcome Brad Cannon for what's new in Python 3.6.
Well, thank you for the warm intro, everyone. So yes, my name is Brett Cannon. I work at Microsoft on the Azure Data Science Tools team. In the 2016 Python core sprint that happened last September at Instagram, 12 of the 16 PEPs I'll be talking about were somehow worked on at that sprint. So I specifically want to thank Instagram for hosting and being the largest financial contributor to that, Microsoft for also being a financial contributor and letting me and my coworker Steve Dower attend, and the PSF for also helping pay for other people to attend. So Thanks to everyone who helped make that happen. It made a huge difference in the scope of Python 3.6. But without further ado, I will jump into this. I'm going to go in numeric order for the PEPs, and basically just try to give you some background information beyond just what the feature is to liven this up a little bit. So without further ado. PEP 468, and I'm here to basically tell you what's new in Python 3.6. Now I should start off and say, everything I'm about to tell you is already written out on the internet, so you can completely ignore me and still get the exact same amount of information, more or less. If you go to docs.python.org/3.6/what's new, /3.6.html. You can also get to it just off of docs.python.org. As I said, everything is there, so if you miss something and want to read up on it later, it'll be there. So yes, if my Canadian isms frustrate you, you can ignore me. Another way you can also do this is I'm going to be going over the 16 Python enhancement proposals that help make up Python 3.6. So if you go to serving keyword argument order, I believe this is Eric Snow's PEP, if he happens to be in the room. He's right there. Basically what this does is whenever you use ** KWArgs, historically it was just a dictionary. So that usually meant everything was randomized and you didn't know what order people actually specified keyword arguments in and make it a function call. What PEP 468 said was we are going to guarantee a mapping, not necessarily a dictionary, but a mapping that will actually keep order of the keyword arguments passed in a function call. Now, in Python 3.6, if you happen to be in Raymond's talk right now, you'd be told about how Python 3.6's dictionary actually keeps the order. I'm going to say this